6. A more traditional differential equation question with a slope field, write an equation of a tangent line. The little difference in the slope field is that instead of having you draw the slope field in this one, they give it to you and want you to draw the two particular solution curves. It's kind of just like playing connect the dots. Go to the point they tell you to start at, just follow the slope fields. So at 0, 2, it's just a horizontal line. And then at 1, 0, you're just following along with the slope field. And just make sure, you know, you do cover like the whole graph, I guess the whole domain is the best way to say it. Now part B, write an equation for the tangent line and then use it to estimate or approximate a value. In order to write an equation of a tangent line, we need a point. Well, if they tell us at x equals 1, we already know the point 1, 0 from above. So in x equals 1, y equals 0. And then dy dx, we sub in that x and y. So it's going to be 1/3 of x, so 1/3 times 1, times y minus 2, so times 0 minus 2 squared. So that gives us 1/3 times negative 2 squared, or 1/3 times 4, or 4/3. So our line is y equals 4/3 times x minus 1. And now use it to approximate, how'd they say, approximate f of 0.7. So you put 0.7 in for x. And y is going to be approximately equal to that value. So 4/3 times negative 0.3 gives us y is about negative 0.4. Now the last part, solving, getting the particular solution to the differential equation at 1, 0. So we have dy dx, separate your variables, put your x's with your x's, your y's with the y's. Cross multiply if you have to, however you want to think of it. But you get dy over y minus 2 squared equals 1/3 x dx. Now rewrite that. That's really y minus 2 to the negative 2 dy equals 1/3 dx. U sub, u is y minus 2, so du equals dy, so we really have the integral of u to the negative 2 du equals 1/3 x dx. When we integrate 1/3 x dx, we get 1/3 times 1/2 x squared. When we integrate u to the negative 2 du, add 1, we get u to the negative 1 divided by negative 1, or negative u to the negative 1 equals 1/6 x squared plus c. Don't forget the plus c. Sub your y minus 2 back in, and now solve for c. So when x is 1 and y is 0, we get 1/2 equals 1/6 plus c. Using a little arithmetic, 3/6 equals 1/6 plus c. So 2/6 or 1/3 equals c. So now we go back and sub that in. We have negative 1 over y minus 2 equals 1/6 x squared plus 2/6. I kept it 2/6 so that on the right side I could write it as 1 fraction. So negative 1 over y minus 2 equals x squared over 2, x squared plus 2 over 6. And now here's where you can use a little trick. When you have a proportion, when you have two fractions equal to each other, if you flip both sides, it's still a proportion. It's still a valid equation. So I flipped both sides and I moved the negative over to the right. So now we have y minus 2 equals negative 6 over x squared plus 2. And solving that for y equals negative 6 over x squared plus 2, and then plus 2. So this question, I think differential equations will be on there. In what form, I'm not really sure. I don't know that it'll be this type of question. It, again, I think like I said on the 2019, it might be more like that, the way they put it on 2019, where it's part of another problem, more like the little weight of the bird question we did in class or on the last test on differential equations.